Presenting NAAMSE, Neural Adversarial Agent Mutation-based Security Evaluator. We have hit a turning point in AI. We aren't just building chatbots anymore, we are building autonomous agents. Nearly 80% of organizations are now deploying agents that can execute code, touch PII, and manage live databases. But as the agency increases, so does the attack surface. Prompt injection vulnerabilities have exploded by 540% in a single year. In this new world, a jailbreak isn't just a funny chatbot error, it's a direct backdoor into your enterprise infrastructure. The problem is that our current defenses are static. We're trying to stop generative adaptive threats with manual red teaming and fixed prompt lists. It simply doesn't scale. That's why we built NAAMSE. We moved beyond static enumeration to automated evolution. Instead of running a fixed checklist, NAAMSE uses a neural mutation engine. We start with a foundation of over 125,000 adversarial prompts and apply more than over 25 different mutation types, everything from persona shift to complex encoding obfuscation. The real magic is the feedback loop. It's a mixture of experts and PII behavior scorers to evaluate every response. If a mutation works, NAAMSE learns from it, feeding that success back into the engine to see the next, even more sophisticated generation of attacks. We are fighting generative threats with generative defense. However, security can't be a blunt instrument. If you implement guardrails that are too aggressive, you hit the over-refusal paradox, where your agent is secure but becomes useless because it refuses legitimate user requests. NAAMSE solves this by treating utility as a first-class citizen. We run a parallel benign flow of over 50,000 prompts through that same evolutionary pipeline. We pressure test the agent to see exactly where safety filters starts to break the user experience. The result is a dual metric audit. We plot attack success rate against false positive rate, giving you the data you need to find the sweet spot, maximum resilience with zero utility loss. Let's look at a specific example to demonstrate how NAAMSE works. The system begins with a seed prompt that evolves over time. Since we don't initially know the model's specific weaknesses, NAAMSE starts by exploring random clusters. Here it successfully identifies a prompt with a high potential for a jailbreak. Notice that instead of issuing a hard refusal, they engages by asking clarifying questions. This results in a score of 80, which was vulnerability. But it's not a complete breach yet. Now that we have identified a successful attack vector, we switch from exploration to mutation to refine the attack. Here, NAAMSE applies the dark side mutation, which injects fake authoritative sources to pressure the AI into compliance. You can see the score bump to 90 as the model begins to comply with our request. To perfect the attack, we then apply the many-shot jailbreak mutation. This technique provides the model with examples of successful harmful responses, priming them to follow the pattern. This achieves a perfect score of 100, as the LLM provides a detailed, unrestricted response to the harmful query. Taking a step back to view the full report, we tested 15 prompts and found multiple jailbreaks, maintaining an average score of 54. The graph clearly illustrates our strategy. We struggled initially during the exploration phase, but once we identified a vulnerable cluster, we rapidly optimized the prompt to the most potent version. Having maximized that attack, the system then returns to exploration to find new vulnerabilities.